Ladies and gentlemen, welcome back to Principles of Technology. Today we're going to deal a little bit with velocity, finding average velocity, and we're going to do this working with some Hot Wheels cars. So maybe when you were a kid you had Hot Wheels cars. I don't know if that's still a thing or not, but when I was a kid I had Hot Wheels cars and we have them in here now. So what we need for this experiment, we need some Hot Wheels track, we need some of the track connectors. Nice and easy, they slide in, and you will notice that there is a little blue dot that slides in. Whenever you're taking them apart, push in the blue button and take them apart. So if you have any like this at home and you want to play along and do this at home, feel free. They go together fairly easily and they lock in place. One of the other things you're going to need is a slice of paper. I prefer graph paper, it just makes things easier. I can keep things organized and lined up. You're also going to need something to create a little bit of a ramp with. However, since we're just starting velocity and just starting all of this information, where you're going to measure time of your vehicle, you don't want it to be on the sloping part. You want it to be only on the flat part. That's going to be hard enough to deal with as it is, and dealing with the slope is going to be way more complicated. So we're going to keep this as simple as we can. We're going to just kind of walk through it and we're going to see what we can get. So I have two different cars that we're going to compare. We're going to look at the velocity that they have as we go, and we're going to look at how to calculate that. So if you remember back from your notes, velocity is the distance traveled divided by the amount of time it took to get there, or the amount of time it took to travel that distance. So when we set up our experiment, we're going to do it very simply. We're going to use a meter stick. Okay, nice meter stick. And we are going to place it right next to the track because that will make our life much easier. And I am about making life a little bit easier when I can. So we are going to use a meter as our distance. I lay it right next to it, that way I don't have to put any tape down, don't have to put any markers, beginning of the meter stick, end of the meter stick. So if we know how far it's going, 1 meter, we just need to find the time it takes to get there. Now, anytime you're doing an experiment, you don't want just one value, right? We always want to take more than one value. We want to try this multiple times. So what I would do on my slice of paper, I'm going to label it blue car and pink car. And we're going to do 3 trials for each car. Why 3 trials? It's an odd number, so that's good, because if you only have 2 trials, well, you can make a straight line through any 2 points. It doesn't really do us any good in science whenever we're looking through and we're trying to analyze our results to only have 2. So we go 3. It's kind of the bare minimum. 5 is way better, but we'll go 3 for this example. So here's how my paper is set up. We've got blue car, 1, 2, 3, pink car, 1, 2, 3, and what we're going to do is we're going to record the times. So the other thing that we need to have is a time recording device. So I happen to have on my phone my stopwatch. We're going to use the stopwatch to take the time. So when it hits this end of the meter stick, I start it. When it hits this end of the meter stick, I stop it. And we're going to use that time as the time it takes to travel that 1 meter. So the other thing that's very important, you can drop this car from anywhere on that ramp. You can start it anywhere on the ramp. You want to start it at the same spot, so that way you're getting the same velocity each time. You don't want that variable to change. Remember when we talked about constants and controls and variables. So we want to keep as many of our variables steady as we can, and to do that, we start the car at the exact same place every time. One of the questions you could have going into a lab like this is one of these cars faster? Is this one faster because it's more aerodynamic? Is this one going to be faster because it's got orange wheels and it's more designed like a stock car which is used for racing, and this is more of a futuristic thing? I don't know. You can have it set up any way you want. So we're going to run through these. We're going to do 3 trials for each one. So we're going to start with our pink car. pink car, and so 0.79 seconds for the first one. Notice there's something at the end to catch it. I don't want to have to chase this car all the way down. So we'll make life easy, put something there. We're going to reset our timer. We're going to do it again. 0.74. And when you're writing these down, put the units with it. Remember, seconds is abbreviated just S, not SEC. So when you're writing down the abbreviation for seconds, please use that S. Reset our timer. We're going to go for our third and final run. Ooh, this one's 0.9. So there's our 3 runs with the pink car. 3 runs with our blue car. Reset our timer. That didn't work. Bad data. Didn't hit stop in time. .77. Reset. And 0.69. And last but not least, 0.75. Here's what I have as my data list. What we're going to do with this now is there are 2 different ways that we could average it. We could average the time first and then find the velocity from that, or we could find each individual velocity and then average the time or average the velocities that we find. I'm going to do it the simple way, which is finding the average first and then just finding one velocity. So if you remember, finding an average, you add up all of the numbers and then you divide by the number of numbers there are. In this case, there's 3 numbers. So we're going to add, for the blue car, 0.77, 0.69, and 0.75. Use our handy calculator on our phone here. And that gives us 2.21. We're going to divide that by 3, which gives us an average time of 0.737 seconds. So now that is for our blue car. Our pink car, we're going to do the same thing. 0.79 plus 0.74 plus 0.90. It gives us 2.43. And we're going to divide that by 3, which gives us an average time .81 seconds. So what we can tell just from our average times, which I have worked out there for you, what we can tell from our average times is that the pink car was taking a little bit longer. So the pink car was traveling slower. We expected to have a smaller velocity. Now again, remember, velocity is distance divided by time. So if we remember, our distance was 1 meter. Each of these velocities is going to be 1 meter. And we're going to divide it by whatever that time was, that average time. So for our blue car, we get an average velocity of 1.36 meters per second. So again, remember, whenever we're doing this, our units that are in the fraction, they carry down into our answer. So there's meters on the numerator, seconds in the denominator. So our units here are going to be meters in the numerator, seconds in the denominator. That's the easy way of keeping track. For our pink car, we're going to do the same thing. So 1 meter divided by 80.81 seconds. .23 meters per second. The results that we have indeed tell us that our pink car was moving slower. Two things we can get out of this experiment. Two reasons why we're doing it. One, looking at how we set up experiments. Nice, simple, basic experiment. And two, calculating velocity. These are two things that you're going to need to be cognizant of as we go through the rest of the class. So we're going to be setting up some simple experiments. We're going to be setting up some that are a little more complex. This was pretty nice, basic, easy. From here, we're going to start talking about acceleration, but you'll notice in our setup here, there should be no acceleration. That's why we didn't measure anything on the hill. Accelerated motion is way more complicated. We start easy, first basic motion, and that's what we did here. Hopefully this makes sense. Hopefully you followed along and you can actually do some of these calculations. Thank you, ladies and gentlemen. We'll see you again.